All right, so here f of x is, say, x squared minus 3x on negative pi to pi. And the question is, find the Fourier series. Okay, now recall that Fourier series is, well, let me write it here. Fourier series is rewriting the function f of x as a sum of sines and cosines in the following form: n equals to 0, no, n equals to 1 through infinity of an cosine nx plus bn sine nx. And you might wonder, where did this come from, a0 over 2? Well, what is cosine 0 of x? Cosine 0 of x is? Cosine 0 x, well, 0 times x is 0, so cosine 0 will be 1. So when n is equal to 0, if you include the term, if you start from n equals to 0, you will get an times 1, and because sine 0 is 0, you won't get b 0 at all. So you will get a0 times 1, and then no b0. So you will get a constant term if n is equal to, if you make the series start from n equals to 0. But instead, I made the series start from n equals to 1 because b0 really doesn't appear if you start from 0. And instead, I put the a0 as a separate entity here. However, there's always this debate on which formula to use. So some books have a0 just by itself, exactly what you would have had if n is equal to 0. But then the formula for a0 looks different from other ones. Now, if you put a0 over 2 here, then the formula for a0 looks exactly like the formula for other ones, and therefore it's easier to remember the formula for getting these constants. So in different books, they have different formulas. The one that I go with is a0 over 2, which I like more, but I've seen some other books where they have a0 by itself, but a0 is defined in a different way. Okay. All right. So last time we learned that to get an, you have to integrate the function. You have to integrate the function from negative pi to pi function against cosine nx dx, and you have to divide by 1 over pi. And to get bn, you have to do the same, exact same thing, except because these are coefficients of cosine nx, you have to integrate against these are coefficients of sine nx, you have to integrate against sine nx dx. Okay, so these are the formulas for getting an and bn, and your final form of the answer should be in this form. Okay, a0 over 2, and then plus whatever you get should be there. Okay. All right, now let's try to actually do the computation. Solution. So these are the formulas. This is the question. Let's start with the solution. Okay. And the solution always goes by the following format. You look for a0 separately, and then an for n 1 or greater, and then bn for n 1 or greater. Okay. So you have to find a0, an, bn. You have to do 3 intervals. You have a question?
Yeah, the n in the a n and bn formulas,
Right.
that changes with the n in the sum up there.
Right, right. See, I mean, if you wanted to know a3, you would multiply fx by cosine 3x and integrate. But you would, in many cases, you can compute this with a generic n. So we will do that. We're not going to be, I mean, in the series solutions, we kind of didn't go for the general term. We just plugged in 0, 1, and 2 into the occurrence relation, and then we got the values for A1, A2, A3, and so on, right? For Fourier series here, we will just calculate with generic n, and it won't be too bad. All right, so let's try it. A0 first. A0 is 1 over pi, according to that formula, negative pi to pi of f of x times cosine of what? It's A0, so what should I put for cosine? Cosine 0x. And what's cosine 0x? It's just 1, right? So fx is this much, and cosine 0x is 1, so I just didn't write it at all. Times 1 is nothing, so if you want, you can put times 1 dx, that's fine. Okay, let's continue with the calculation. 1 over pi times 1/3 x cubed minus 3 over 2 x squared. And you're plugging in pi and negative pi. Oh, you know, I'm doing something. Let's take a shortcut. Rather than calculating both of them, I know one of them is 0. Which one? Is the integral of this 0 or integral of this 0?
Probably 3x,
Why? Why do you think so?
because when you take the derivative of x squared, you still get x, but when you take the derivative of
No,
3x,
no.
Because it's an odd function.
Because it is an odd function. Yeah. X is an odd function, right? So one side goes up, the other side goes down. So when you integrate from negative pi to pi, it gives you 0. Where x squared is, it's an even function, right? So what do you do for even functions? So maybe I should write it here. So the odd functions, when you integrate over a symmetric domain from negative pi to pi, it's a symmetric domain, right? It becomes 0. For even functions, what do? You integrate from, instead of negative pi to pi, you integrate from 0 pi, and then what do? You double it, right? So you do 2 over pi of x squared dx, and you integrate from 0 to pi. And that is actually a lot simpler than having to do the calculation for both pi and negative pi. Okay? So it's 2 over pi, 1/3 x cubed, pi and 0, and then plugging in 0 doesn't do anything, so plugging in pi only, you get 2/3 pi and then pi cubed. And one of the pi's cancel and gives you 2/3 pi squared. So that's what you get for A0. Okay, now let's go for AN. For AN, 1 over pi, negative pi to pi, x squared minus 3x times cosine nx. Okay, for cosine nx, you know that this is an even function. Even times even gives you what? Even function. Odd times even gives you? Odd function. So this times this, when you integrate, what would you get? 0. If you integrate over a symmetric domain, you're going to get 0. Even times even gives you an even function, therefore what should you do? Double and make the integral from 0 to pi instead of negative pi to pi. X squared cosine nx. And it really simplifies your calculation if you use this odd and even properties. Alright, now we have to integrate this, which requires integration by parts twice. But since I don't like integration by parts, I rather would do tabular integration. It's much faster. Let's do the tabular. You can do integration by parts if that's the only thing you do. So let's try. It's always plus minus d and integral. Never switch these order. It needs to be this form. And then you're trying to differentiate x squared and integrate cosine nx, right? Okay, you start differentiating. X squared differentiates to 2x. Differentiating 2x gives you 2. Differentiating 2 gets 0. When you hit 0, you don't have to compute anymore. And then here's the question. Cosine nx. What's the integral of cosine? What's the integral of cosine first? Sine. It's positive sign.
1 over n.
Yes. When you integrate cosine nx, this n comes up in front as a reciprocal. The reason for doing so is because you're doing the anti-chain rule. It's the opposite of the chain rule. If you were to differentiate this, you would have to use the chain rule, which pulls the inside function out. When you differentiate nx, it creates n, right? And that will cancel with n, giving you this. Okay? So that's why the antiderivative should be this one. If you integrate this again, what would you get? Every time you integrate, this n will create 1 over n, right? So you're going to get 1 over n squared next time. But what's the integral of sine? It's negative cosine, right? And then integrate one more time, you get negative 1 over n cubed sine nx. And then the sign alternates. Then you do this, right? Just like you're shooting missiles. And then if this wasn't 0, then you have to do this integral of the last line. I may be able to show you such an example, but for us, this is all you do. Okay, so according to our tabular integration, this is what we have. It's 1 over n x squared sine nx. Okay, and then minus 2x times negative. Negative times negative positive. That's plus 2x over n squared. I forgot this 2 over pi, sorry. 2 over pi multiplied to the entire thing. 2x over n squared cosine nx. And then it's plus times negative, so it's negative. So it's negative 2 over n cubed sine nx. And you're plugging in what and what? Pi and 0. 0 and pi. Okay. And then there are formulas that you'll be using over and over again. That's the fact that sine n pi is what? What's sine n pi? What's sine pi, for example? Sine pi is 0. Sine 2 pi is 0. Sine 3 pi is 0. So if you draw the graph of sine, you'll see that sine n pi is always 0. How about cosine n pi? So let's try to think about it. What's cosine pi? Negative 1. Cosine 2 pi is positive 1. Cosine 3 pi is? Again, negative 1. So it alternates between negative 1 and 1. If you forgot that, this is how it looks like. Cosine graph is from 0 to 2 pi. It starts from 1. Actually, let's divide this into 4 equal parts. Let's start from 1, 0, negative 1, 0, and 1. And that just repeats. This repeats. So at pi, it's negative 1. At 2 pi, it's positive 1. And then at 3 pi, it's negative 1 again. So negative 1, positive 1 just alternates. And what's another form that also alternates between negative 1 and positive 1? Negative 1 to the n power. Right? And you can check that these are indeed exactly the same for integer values of n. So If n is 3, you get negative 1 to the third power, which is negative 1, and indeed cosine 3 pi is negative 1, so it matches. So we will be using this many times when we calculate this, especially for us. When you plug in pi, what do you get? Sine n pi is? 0. How about here? 0. So the only survivor is cosine n pi, right? When you plug 0 in, what's sine 0? 0. Cosine 0? 1. Sine 0? 0. So the only survivor is this one. So among all these things, we see that in both cases when we plug in pi or 0, the only survivor is this one. Okay? So let's continue on with the calculation. It's 2 over pi. Plugging in pi here is cosine n pi. We said it's negative 1 to the nth power, so it will be 2 times pi over n squared times negative 1 to the nth power. And then when you plug in 0, again, these are 0. But when you see here, there's also an x here, right? So when you plug in 0 into here, what would you get?
0.
You're going to get 0. So when you plug in 0, everything is 0. So you see that this is the only thing. Pi cancels, and you get 4. So you get 4 over n squared times negative 1 to the nth power. So that's your an. All good? Now let's write down these results since we don't have any room to write. We have A0 equals to 2 over 3 pi squared. And then AN equals to 4 over n squared times negative 1 to the nth power. And now we have to find Bn to plug into that formula. Bn, I erased it, but it's negative pi to pi of fx times sine nx dx. So let's calculate this over here. Therefore, Bn is 1 over pi, integral from negative pi to pi. Our function is x squared minus 3x times sine nx dx. Okay, x squared, even or odd? Even. Sine nx, even or odd? Odd. Odd times even gives you? Odd. 3x, even or odd? Odd. Sine nx odd. Odd times odd gives you? Even. So which one survives this time?
Negative 3x.
Negative 3x times sine nx is the survivor. The x squared times sine nx will be cancelled because you're integrating an odd function of a symmetric domain. So we will take twice of integral from 0 to pi of negative 3x times sine nx dx. Okay. And let's even pull the negative 3 out. So you get negative 6 over pi. Okay, now let's do the tabular integration again. Plus minus d integral x, 1 and 0. Okay, and you're integrating sine nx, which integrates to negative cosine 1 over 1 over n appears because of this n. It will be negative cosine of nx. Integrating this again will give you negative 1 over n squared.
Gotcha.
Sine nx, and the signs will alternate. Okay, and then multiplying it this way gives you, first I pull the negative 6 over pi out. Okay. Multiplying it, you get negative x over n cosine nx. And then negative times negative is positive, so it's plus 1 over n squared sine nx, plugging in pi and 0. Okay. Now plug in pi. What do you get? Negative pi over n. What's cosine n pi?
Negative 1 to the n.
Negative 1 to the nth power. Now when you plug in pi here, what would you get? Sine of n pi is
0.
0, so that doesn't give us anything. When you plug in 0 here, what do you get? 0 times anything is 0. And then when you plug in 0 into sine, you get 0. So you don't get anything else. This is the only thing that you end up with. Pi cancels, and negative becomes positive, so you get 6 over n, negative 1 to the nth power. And therefore, we're ready to write down the final answer. We're saying that x squared minus 3x is equal to a0 over 2. So we're taking half of this. What's half of this? 2 will cancel, and you're going to get 1/3 pi squared plus sigma n from 1 through infinity. And then I have to put an times cosine nx. This is our an, right? So we put 4 over n, negative 1 to the nth power, cosine nx, plus 6 over, no, that was n squared. 6 over n, negative 1 to the nth power, sine nx. Put a parenthesis here,
Thanks.
and that's the answer.